This hard drive weighs 150 pounds, and for all of those LBs, you get an insane 10 megabytes of storage. Also, it doesn't work at the moment. It's broken, but I've repaired 2 of these before in the past, so bringing this third one up should be easy peasy, right? Right? This is a Control Data Corporation 9427H Hawk drive, and yeah, for your 150 pounds, you really do only get 10 megabytes of storage. And that sounds ludicrous in the bad way, but when this released in the early 1970s, it was ludicrous in the good way. 10 megabytes was a phenomenal amount of storage space, and the drive was lightning quick compared to the paper tape based systems that were available and in common use on mini computers in that era. So this drive actually kind of changed the landscape of the mini computer industry in the 1970s. Now, when I said it's 10 megabytes of storage, that's laid out in kind of an interesting way. There's actually 2 platters in this drive. The first platter is kind of deep within, and it's fixed and we don't have access to it, and that gives you 5 megabytes. But the second platter is actually removable. You just get the dust cover out of the way like this, and then your 5 megabyte platter pulls right out of the top. And you can close it up, put it on the shelf, and put a different 5 megabyte platter in. Now for this drive, this 5 megabyte platter, we've actually dumped and pulled the data off of it. And it had a lot of really fascinating stuff on it, like a backup of a very early copy of the operating system. Now, this Mini-Centurion that it's currently in is not where this hard drive originated, because I built this Mini-Centurion from scratch. But this hard drive actually came out of a desk system up in Cincinnati at a place called Butler Tech. Now, Butler Tech is a pretty amazing school up in Cincinnati. They have a phenomenal program set up that actually allows students to get hands-on with real deal tech. And the IT department of that school is run by an amazing gentleman named Mr. Hall. And Mr. Hall recognizes the importance of computing history and wants his students to get a proper full experience from new to old. And as a result, he has a desk-based Centurion in the department that students can get hands-on with. This is a gorgeous system, and if he ever decides to get rid of it, I hope he keeps me in mind, because I would love to have it here in the room with the rest of the Centurions. But I also think it's incredibly important for that system to be up there so students can get hands-on with it. Now, there's some pretty important differences between that desk-based Centurion system and the primary Centurion system that's right back here. Now, if you don't know anything about the Centurion, don't worry, I have about 50 videos on this channel going into all sorts of depth about it. But the important thing to note here is that that desk-based system is much older than the system that I have behind me. It has an older revision of the CPU in it called CPU 5. Now, these systems had dramatically different instruction set architectures, and as a result, the software was also dramatically different. So when we pulled data off of this disk pack here, it was a fascinating look into the past and into the history of Centurion. But this disk pack really only told half of the story, because this was just a backup pack, so we need to actually get the data off of the fixed platter out of that system. Now, that would be much more difficult because the system is up in Cincinnati. But Mr. Hall is an absolute legend, and he decided to do a little bit of a switcheroo with me. That older CPU 5 32K memory and Hawk drive all came down here to Texas to be installed in the Mini-Centurion here. And the Hawk drive, CPU 6, and 128K memory card that was originally in this all went up to his desk system to get it up and going at 100%. Now, we got pretty close on that. I did have a bad ribbon cable that blew a hole in our operating system. So I actually need to go back up to Cincinnati one more time to get that system going at 100%. And Mr. Hall, if you're watching, that's gonna happen this year. It's just gonna be a little later this year because I'm still developing the software that will allow me to do that properly. But that means that we now have the CPU 5 here with that fixed platter that hasn't been dumped in this Hawk drive. So we got to get this drive up and going. And it has a couple of small problems, like the locks that hold the dust cover in place have been broken off. However, the bigger problem is that the power supply is broken. It's burned up a transistor, and the switch on the back of it to turn it on and off is broken, so you can't even turn it on. So we've never actually had any power into this drive at all. So we need to get the power supply fixed. We need to fix a couple other the small things, spin it up, get the heads flying, and then pull the data off of it. This drive should come up fairly easily. I hope. It better, because I need it to be up and going for VCF Southwest, because this machine is going to be at VCF Southwest on display. And in order for that to happen, this hard drive needs to be properly functioning. So we're going to dive into it and hopefully get this drive going and the data dumped off of it in this episode so that this machine is ready for VCF.
Let's get started, and first things first, I need access to the drive. So let's pull those epic side panels that John at Kad Industries made up for us off, and then we can actually pull the drive all the way out, making sure to disengage the locks and allow it to come all the way out into the service position. I'll actually support the front of the drive with a chair, as that is a ton of weight to have cantilevered out into open space like this. And dang it, I forgot that my custom-made cabinet here is sized just slightly wrong, and it doesn't allow the capacitor bank to properly flip open. I'll have to push the drive back in and remove the capacitor bank from within the cabinet. With that off now, it's back to this song and dance with the chair, and there's that burned up silicon-controlled rectifier. Boy, it really let loose. Let's get the power supply out by removing the screws that bolt it to the main chassis. There are 3 screws in total around the periphery, and with all 3 removed, the beast of a power supply is free. I need to pull it out the back because, again, space is so tight, and I don't want to scratch my front panel that I just painted in the previous episode. And since we're pulling stuff out, I want to get the air filter off for a solid clean too. Fortunately, it's a service part, so it's actually dead simple to remove.
We've got the power supply out and the air filter out. Now, the air filter is a little dirty. There's some gunk floating around inside of it here, but the filter material itself actually doesn't look that bad. We're going to try and clean this up and reuse it. We don't have a good replacement for these. Normally, you would replace these every year or two, but this one's from 1988, so it's a little bit past its sell-by date. Hopefully it'll clean up and we can use it no problem. The bigger issue is this power supply here. It has a SCR on the top here that has completely melted. And the on-off switch down here is completely broken off. So you can see that right here. There should be a little toggle switch right there, completely shattered. That's going to be an absolute nightmare to replace. So instead of trying to take this thing completely apart, get all the way into there to replace that switch, what I'm going to do is I'm going to replace it with this one. This is a spare power supply that I had from a different hawk drive that's now become a parts hawk drive. Everything inside should be similar enough that it shouldn't make a big difference. They're both rated at 120 volt, 4.6 amps. This one does have good switches on the bottom though, so that's excellent. However, the main power supply board on top here has had a massive bodge wire glued to it, and also its SCR has gone up in smoke. So what we're gonna do is we're gonna take this control board off. We're gonna take this control board and put it on here, but we're gonna replace the SCR first. And then we should have a much cleaner control board on this one, plus working switches, and that should get us up and going.
To get the power supply board off, there are 2 small screws that go through the board right on the edge of the connector to firmly hold the connector in place. Then there are 2 large screws that go through the white ducting, but it seems that one of those is missing already. But with all of those removed, the top PCB and white ducting pull straight up and off together. Then we do the same thing for the other power supply unit. Next, let's get this lower power transistor board off. There are just a few plugs that we need to undo, and then 4 screws around the periphery. Then it lifts right out of the way with no problem. And you can see that the lower housing that has the transformers and that broken breaker is totally sealed up. It would be a right pain to get into there. Next, let's get the pieces outside and give them a proper clean. probably the first time the dust has been cleaned out of this power supply in 40 or 50 years. We'll also give the air filter a good spray down with the air hose too, making sure to get as much gunk and nastiness out of it as possible. We really want that air filter to be as clean as imaginable. Back inside now, let's get that SCR removed. I'll add some fresh solder to the scorched pins just to make life a little easier, but the SCR is so blasted, I'm just gonna snip the legs to make removal easier. After that, I just push the remaining legs out with the soldering iron. I'll try to clean it up as best as I can with some IPA, but the scorching is deep. I can actually see the fibers of the board itself. This thing let loose hard. I'll also go through and scratch off solder mask on the backside just to make sure that the traces are still okay. These could have very easily been burned up when that SCR let loose. And looking at the top here, it looks like maybe that's exactly what happened. I can see kind of two little tabs sticking out from these components, but it doesn't quite look right. Let's consult the schematic. That particular IC is shown as AR2 on this diagram. That is an LM339, which is a quad op amp. It looks like pins 1, 2, 13, and 14 are all tied together, which is the outputs. So all four outputs of that op amp are in parallel. They go through R38 over to Q9, which must need a lot of push to drive it. But looking back at the PCB, they clearly aren't connected to the component I initially thought. So it looks like CDC just put strange little pigtails on some traces. Weird, it totally threw me for a loop. But since we're looking at the schematics, the blown SCR looks like Q3 on this diagram. That appears to be a 2N4441 silicon-controlled rectifier. I may be reading the schematic wrong here, but to me it looks like the remote trip breaker controls whether the 5-volt return is allowed to connect to the overall ground using that SCR. At any rate, it clearly went up in smoke, so let's get a new one in place. And the replacement is a bit smaller of a package, but it fits well enough. I'll solder both sides of the PCB to make sure it's making a good connection to all of the traces, which were a little questionable looking. Then we just toss the upper PCB with duct back in place, tighten everything down, and finally slide the whole power supply back into the drive. We're not quite ready to power it up though. I want to get in there and make absolutely sure that the heads are clean. So the removable pack comes out. Then the front panel needs to come off, and it's held in place with 4 screws, 2 per side. With all 4 of those removed, it pulls straight off the front. I just got to remember to disconnect the relatively short grounding strap. Then to get to the fixed platter and the heads a little easier, let's get this cover off. It's held in place with 3 long screws. Then it lifts straight up, revealing the fixed platter underneath. But we're not out of the woods yet. The removable pack sector transducer is still connected. I find that I have to rest the cover on its side so I can disconnect the wire. It's a little fiddly and feels terribly dangerous, but I've done it this way dozens of times and it seems to work the best. With that out of the way, we can finally get a good look at that fixed platter, and it is absolutely gorgeous to see. It looks clean without any evidence of crashes. It does look like there's a little bit of gunk on the platter, and Canned Air didn't want to blow that big piece off, so let's get it off by hand. I'm going to use these MG Chemicals chamois swabs that June hooked me up with. Thanks, June. These things are awesome. I'm going to be buying more of these for sure. I'll just soak one in alcohol and use that to pick up the gunk. Then I'll take another one to dry and clean up the alcohol left on the surface. I was a little too slow, so there's a bit of residue left over. So I went back later and cleaned that up much better. To get the heads clean, I just soak another one of these chamois swabs in alcohol, then slip it in between, working it back and forth. The lower heads are much harder to reach, but I think I managed to get in there well enough. Either way, the swabs came back clean both times for the heads, so I think the heads are in pretty good shape. I'm really happy with that, so let's go ahead and get this thing back together. Getting the cover plate back on is equally as terrifying. One slip of the hand and this could fall and destroy the platter and all the data on it. Fortunately, I managed to hold it together long enough to get it down incident-free. Let's make sure the heads are firmly locked and unplugged. Then let's spin this bad boy up to purge for a while. And yeah, that's sounding pretty good. Let's see if the spindle looks like it's up to speed. Looking underneath here, you can really see the fixed platter sectoring ring spinning like crazy. I'm really happy with that. Now let's just let it run for the next hour or so.
I let it spin for about an hour, which should be enough, hopefully. So I think we're ready to try and load the heads for the first time in who knows how many years. So I've spun it down, unlocked the heads, plugged them back in. I also plugged the hard drive into the computer. The computer is on, plugged into the terminal, sitting at the D equals prompt. We're gonna spin this drive up, let the heads load automatically, and if everything sounds good, we're gonna try and boot into something. Hopefully we can find some interesting stuff in there. Here goes nothing. I'll push the start and stop button here. It's gonna start spinning up. It should take 50 seconds before the heads will automatically load. And then, well, let's just hope for the best. Ooh. Heads have loaded. I don't hear anything bad. We've got a ready light going on here, no errors. Oh, I think that's good news. I think we're ready to push buttons. We're gonna try and boot from the fixed, so I'm just gonna type H1. Oh, that's not good. Gave me an error. All right, let's try booting from the removable. We know that one's good. Let's do H0. That gave an error as well. Oh, dang it. Okay. We should be getting 3 RTZs there, and then it should load. But the fact that we're getting error is no me gusta. Perhaps I have something hooked up wrong? Oh, I don't know. This is really not great. Oh, man. All right, I've got the CPU 6 in there, the known good disk 1, disk 2 controller card, and the diag card, so we can get to a memory monitor. So the computer is all in a completely known good state, and let's start trying to control the Hawk drive directly from memory, and we can do that with MMIO addresses. So MF148 here is the command register. So if we do a 03 on that one, it should do an RTZ. Yeah, okay. So now let's do a read on track 0 here. So we'll do MF14800, that's a read operation. And then we'll check the status register. That's gonna be MF144 and 145. And we get, not what we should. Dang it. All right, so we get 10B0. 10, if I'm looking at this correctly, says that the drive is good, but we're getting a format error. And then B0 is write protect on cylinder, and drive ready. So the drive looks like it's in totally good shape here, but we're getting format errors on track 0. That is not great. All right, what's going on here? Nothing's ever easy in this room, and the computer gods apparently want me to work for it today, so we gotta just keep plugging away at it. There is some good news though. The power supply seems to be working perfectly, so that new SCR we put in seems to be doing the job, and I pulled the disk pack out and looked at it, and the heads didn't crash. That is a massive amount of stuff taken care of. But we're still not reading any data off of it. When we look at it in the memory monitor, we're getting a format error. And so that tells me that it's just not reading any bits. The heads are flying over the correct places, but they're not picking up any magnetic transitions. Now this can kind of be lumped into 2 main faults. We could have a mechanical fault or we could have an electrical fault. If it's an electrical fault, it has to be limited to the Hawk drive itself, because the disk 1, disk 2 controller card and the computer are known good, the CPU is known good, the memory is known good. It's all known good stuff down there. And so we could have blown heads, I've had that problem before, or we could have a bad IC on one of the controller cards in the Hawk itself. Both of those are a nightmare. But I think what's more likely is that we have a mechanical fault, and that is that we have misaligned heads. Whenever you power this drive off, you push the button and the voice coil pulls the heads completely off of the platter. Now it pulls them off with relative force, And there's these little rubber bump stops that are supposed to stop it when it reaches the end of travel. But over the years, those rubber bump stops tend to deteriorate, and they've done so on this one. So you get this sickening metal on metal sound as it just slams into it. And that slamming can create a sharp impact that actually slides the heads out of alignment. That's exactly what happened on my other Hawk drive that's on the primary system. So we need to pull the back of the drive apart so we can get to those rubber pads and clean up the mess that's going to be made in there, put new rubber pads in, put it back together, spin it up, fly the heads, send them out to a track about midway out, and then try to align them to that data track.
To get that big honkin' magnet out, let's first unplug all the connectors going into the analog board on top of it. Then let's get the velocity transducer out by removing the plate and just sliding it out, which is what I would have done if I had remembered the transducer has a set screw. But since both of my brain cells were saturated at this point, I instead gave up on trying to remove it, thinking that it was just locked in place, and opted to just be extra careful. This was kind of dumb, but the magnet is held in place with 2 bolts through the bottom, and with those removed, the whole thing slides straight back, and I had to be super careful not to twist or angle it, as that will bend or break the velocity transducer, but thankfully nothing dramatic happened. And look at that, see those little cross-shaped pieces? That's where some rubber bump stops are supposed to be. You can see the remains of one on the bottom, but most of it has just turned to dust. I'll vacuum up as much of the nastiest as I can, and then remove the remnants of the previous bump stops. The original bump stops were just rubber with threaded studs on it, and with the rubber gone, all that's left are the studs, but they can be unscrewed, giving us a nice flat piece to work with. Then I'll just drop down a bit of super glue and push a new little rubber foot into place. I got these at the local hardware store and they feel like they might be a little too stiff, but this is relatively easy to access, especially now that I remember that the transducer has a set screw, so I can change it in the future if need be. With the 2 new bump stops installed, we can now slide the big beast back into place. After getting everything tightened down, I'm going to use a golden oldie here, CCDP. This is a custom program written by Gavin that we'll use to align the heads. Whenever the Centurion disk control cards read a sector, if it can't read the data or something goes wrong, it'll give one of 4 errors. A format error, a sector address error, a CRC error, or a timeout error, which all pretty much mean what they say on the tin. If we get any of these, the CCDP program drops an X on the screen. However, if we get a clean read, it drops a dot. And as you can see here, we're still all X's. That means that we're aligned incorrectly. So it's time to go in and actually adjust the heads. They're locked in place with a little clamp. Once you loosen that up, you use this unique tool to hook around a brace and engage the roll pin with the head itself. Moving the tool left or right leverages the roll pin against the brace and pushes the head forward or backwards. We just do this until CCDP gets happy and starts spitting out dots, which it just decided to do. That means that the head is on the correct cylinder, it's reading the correct sector address, reading all the data, and the CRC is checking out. That is awesome. So we need to repeat this for the lower head as well, and sure enough, dots on it too. You can see I occasionally get an X on the upper head, and this is because as I move the lower head around, I'm flexing the whole assembly just enough to miss some data. I'll go through and try to get that head aligned a little better here in a second, but after doing the same procedure on that head and the fixed platter heads, let's get that data off of there. I'm not even going to spin the drive down. Let's just go straight into dumping the data. I'll fire up the read program and, oh, that's interesting. The first 10-ish sectors errored out, but then it started reading fine after that. I'll just have to keep an eye on it, I guess, but that many dots means that we're getting good data off the drive for sure.
Excellent news, data is coming off of the Hawk onto the hard drive of the laptop. We are backing that fixed platter up. Now, I didn't want to spin the drive down and change a bunch of settings over, so we're still living a little dangerously here because the Hawk drive is still set up in head alignment mode, which means that if the power goes out, an emergency retract will not happen. And that is dangerous because the platter is going to slow down and the heads will crash into them. So I have to be very vigilant and unload the heads by hand if the power goes out for whatever reason here. Hopefully that doesn't happen, but it means I gotta sit here and babysit it for the next hour and a half or so. Now, this is only possible because, well, Gavin's CCDP tool is stunning. Gavin, your tool is proving to be indispensable still to this day. I cannot believe that you wrote this a year and a half ago without understanding the full instruction set. It absolutely blows my mind. The amount of skill and talent you have is just, someday I hope I can get to half of that. But it saved our bacon. We were able to align both the fixed platter and the removable platter heads, and we're able to dump the data straight off. Now, on that data, we got some bad sectors right at the beginning on track 0, but it wasn't for the entire side. So that may still be okay. And as a matter of fact, since then, every single sector has read perfectly. Hopefully we can keep that going to the end. But it'll be really interesting once the dump is finished to try and boot into it, because that fixed platter may actually still boot. But that's gonna happen like an hour and change from now. So I'm gonna pull up a chair and watch this like a hawk, and pun intended, I guess. Oh, that's silly. I'm out of here. I'm just gonna wait. All right, we're just gonna go for broke. I've got the CPU 5 back in there, the 32K memory back in there, and the original Disk 1, Disk 2 controller card back in there. And this is the setup that's going to VCF Southwest, so it better work. I do have the Hawk drive spun up, the heads are loaded, and we're sitting here at the D equals prompt from the Bootstrap ROM. If I type H1, it should boot, if there is bootable material on that fixed platter. So, fingers crossed here. Let's do H1. Nope. Did the same thing. It just did a single RTZ and then throws an error. You know, maybe just the Whipple is wrong on it. Let's see if we can boot into the removable platter. We know that has a good operating system on it. We ripped that many moons ago. So we'll hit the reset button here, and I'll do H0. Yeah, there we go. 3 RTZs. That's exactly what should have happened. Yeah, DOS 5.6, Centurion 3. This is excellent news. S equals 0. Because we want to make sure that the system disk is the removable platter. We'll hit enter on that. The date is 08/24/89. We'll hit enter on that. And exec ready. We're fully into the operating system. If I do a .status, yeah, we can see, okay, so 0 is the removable platter, that system. 1 here is just showing all stars. So it's not reading that initial track on disk 1 correctly. Man, I'm not sure how best to tackle that. It's a new day and a lot has transpired in the last 12 hours. Not all of it good. But as you saw where we left off yesterday, we were able to boot up into the operating system on the removable platter, and we also had the fixed platter up and working. We're able to pull all the data off of it. Now, the excellent news is that we spent a ton of time digging through that fixed platter, and it is identical to the removable platter. The removable platter was simply a backup of that fixed platter. So that means that all we really need to do is copy the removable platter down to the fixed, and we're good to go. But why is the fixed not readable within the operating system? Well, remember when we pulled our dump, the first 8 or 10 sectors were bad, and then everything else after that was good. Well, those sectors are the initial program loader. That has to be good in order for the operating system to see it. So what I think happened here is that as the heads were starting to become misaligned, the drive would no longer boot. So they threw in the removable pack and copied down a new initial program loader without erasing all of the rest of the data. So now you're in this weird situation where all of the data is on one alignment and the initial program loader is on another alignment. And so that's why we're not seeing it in the operating system. So the logical step then was to just copy all of the data from the removable pack down to the fixed pack. And that should be easy But it's not. First of all, the CPU5 OPSIS is very strange and missing a lot of the things that we're used to with the CPU6 OPSIS, but more importantly, the Hawk drive is misbehaving whenever we try to get it to do anything with that fixed platter. Sure, it read all the data fine, but copying data requires writing and erasing, and it's not doing that. So we hopped into TOS, which is a memory monitor, and dug around, and after hours of troubleshooting, we're like 99% certain that the lower head has a bad coil in it. Could be a bad write coil, could be a bad erase coil, but one of them is bad, maybe both. So unfortunately, this drive has one bad head out of the 4 heads. That means that that fixed platter is pretty much useless to us until we can find a replacement lower head. And that's tough. I've been looking for one for a couple of years now and still haven't come across one. So the search will continue, but in the meantime, we have the removable platter in there, fully readable, and as you can see, sitting in here running Lunar Lander. So for VCF Southwest, this will be yet again a one platter only Hawk drive, but it will have a full operating system on it. We will have multi-user going on, and we will be able to run some pretty interesting stuff. We just don't have a fixed platter. So we almost got there in this episode, and I think we're close enough for the event. If you want to see this machine in person, come hang out at VCF Southwest. I don't remember what the dates are, but they'll be floating around somewhere. There'll also be a link in the description for more information. So I hope to see you there, and I want to thank you guys so much for watching, and I hope to see you in the next episode.